Hello and welcome to today's video. We will be looking at vector multiplication. Now if you're new here, please go back to the previous videos. We have already done matrix addition, matrix subtraction, scalar multiplication, and we've also done matrix multiplication. So let's dive in vector multiplication. Now, if you can remember, we dealt with vectors previously, and we said that a single row matrix is called a row vector, and a single column matrix is called a column vector. So in vector multiplication, we're just going to apply the same rules as we applied in matrix multiplication, whereby we multiply the rows and the columns. Let us look at an example. We have matrix A with the following elements. Then we have matrix B with the following elements. 1, 2, 8, 9. Just an example. Now remember, we said in matrix multiplication, the first thing you do is establish the size of the matrix. Now, matrix A is a 1, it has one row by 1, 2, 3 by 3 columns. 1 by 3 matrix. Matrix B is 1, 2, 3, 3 by 1, 2, 2. So, we did mention that for you to be able to know whether the multiplication is feasible, the number of columns in the first matrix must be equal to the number of rows in the second matrix, like that. We looked at that in the previous video. And the matrix you're going to get after multiplication, that is A, B, should be equal to the number of rows in the first matrix and the number of columns in the second matrix. So the size of the matrix you're going to get, matrix AB, should be a 1 by 2 matrix. We did look at that previously. Now we're going to multiply A and B. We did say we multiply the rows by the columns. So what we will have is 5 times 4. You add 6 times 1. 6 times 1. 7 times 8. You add 7 times 8. Remember, we're multiplying the rows and the columns. So we're multiplying this with this. Let us move to the second column. 5 by 3. 5 times 3. You add 6 times 2. 6 times 2, you add 7 times 9, like so. Quite easy. That is the matrix you're going to get. Remember, you're taking the rows, multiplying by the columns. Like that. Rows times the columns. So we're going to work this out. So after working it out, that is what you get AB to be. So let us look at what is the size of this matrix. It is a 1 by 1, 2. 1 by 1, 2. It is a 1 by 2 matrix, as it should be right here. So that means I told you that is how you're going to know whether you've done the multiplication correctly. Yes? Quite easy. I hope you're together. Now we're going to look at zero matrix next, and a zero matrix is a square matrix where every element is 0. It is that simple. It is a square matrix where every element is 0. What is a square matrix? We looked at that previously. It is a matrix where the number of rows and the number of columns are equal. So it will be, if it is a 2 by 2 matrix, it will be like that. If it is a 3 by 3 matrix, like that. Okay, so that is a zero matrix. Now Just like in normal numbers, if a matrix is multiplied by a zero matrix, we obtain a zero matrix. Just like the way if you multiply a number by 0, you obtain 0. The same case applies to multiplying zero matrix with other matrices. You will obtain a zero matrix. Let us look at an example. So we have matrix A, which is 3, 4, 5, and 6. And then we have matrix B, which is a zero matrix, which is 0, 0, 0, 0. We are going to use the same rules. This is establish the size. This is a 1, 2, 2 by 1, 2. This is that's a 2 by 2 matrix. This is a 1, 2 by 1, 2. 2 by 2 matrix. Those two are the same, and we should get a 2 by 2 matrix after multiplication. Now, let us do the multiplication. Let me try to work it out here. Now, we said you multiply the rows with the columns. So, it's going to be 3 by 0 plus 4 times 0. And then the second column, it's 3 times 0 plus 4 times 0. And then the second row with the first column, 5 times 0 plus 6 times 0. The second row with the second column, 5 times 0 plus 6 times 0. So it is, the answer we get is, which is A, B, is 0, 0, 0, 0. Just as we said, if a matrix is multiplied by a zero matrix, we obtain a zero matrix. Simple. Now, next we are going to look at a unit matrix or identity matrix. Now, this is a square matrix whose top left to bottom right diagonal consists of ones, while the rest of the matrix consists of zeros. So, top left to bottom right diagonal consists of ones, and the rest of the matrix consists of zeros. Let us look at an example. We already established that a square matrix is a matrix whereby the number of rows and the number of columns are equal. So let us look at an example of a 2 by 2 unit matrix. So top left to bottom right. It is a 2 by 2 matrix. So top left to bottom right consists of ones. The rest are zeros. Like so. Let us look at a 3 by 3 matrix. So top left going all the way to bottom right consists of ones. The rest zeros. So that is a unit matrix or an identity matrix. Now, just like with normal numbers, where a number multiplied by 1 equals to itself, the same case applies with matrices. A matrix multiplied by a unit matrix equals itself. Let us look at an example. We have matrix A with the following elements, like that. And then we have matrix B with the following elements. So it's 1, 1. Matrix B is a unit matrix because the top left to the bottom right consists of ones. All the others are zeros. So we're going to still use the same rules of matrix multiplication. So we establish the size of the matrix is a 1, 2, 2 by 1, 2. A is a 2 by 2 matrix. B is a 1, 2, 2 by 1, 2. If you knew, we look at to establish the size of the matrix. We start with the rows 1, 2, 2 rows by 1, 2 columns. Okay, and then the next step is we look at that. They are the same, so it is feasible. We should get a matrix of 2 by 2 when we multiply the two matrices. So matrix A, B should be a 2 by 2 matrix. Now, let us do the calculation. We said you start with the rows, multiply that by the columns, like that. So we get matrix A, B equals to 1 times 1 plus, that is 1 times 1 plus 6 times 0. 6 times 0. We go to the second column, the first row, the second column. So it's 1 times 0. You add 6 times 1. And then we go to the second row, first column. Second row, first column. It is 2 times 1 plus 3 times 0. And then second row, second column. It is 2 times 0 plus 3 times 1. 2 times 0 plus 3 times 1. So we calculate that. So after we calculate, that is what we get, the same as matrix A that we started with. So when you multiply a matrix with a unit matrix, you get what? You get the matrix. Okay. Now, it is important for you to note that a unit matrix must always be square. The number of rows must be equal to the number of columns, must always be square. And of course, after you get the answer, you look at the size. It's a 1, 2, 2 by 2 matrix, just as we expected right there. So I hope that's clear. I hope I was able to explain it as clearly as possible. So just keep practicing. It gets easier with time. The next episode, we will be looking at matrix inversion. So please make sure you practice from the time we started with matrix multiplication, introduction, matrix multiplication, subtraction, and all the way up to here. So next episode, we'll be looking at matrix inversion. Thank you so much for watching, guys. Please subscribe to the channel. Leave a comment if you have any, a question if you have any. Just leave it in the comment section and I will get back to you. Thank you and God bless.